Hello. May I assume that most of you are familiar with the St. John's program? Okay, in that case, you know that math is not a dead body of knowledge in St. John's. It's a live, creative endeavor. Dostoyevsky's mother and brother and wife all died of tuberculosis. His descriptions in his novels, the vivid, long, slow, torturous suffering of TB really stuck with me as a student, but I didn't imagine then that I would be using math to work to eradicate TB. At the same time, in the early 80s, I believed that tuberculosis was something that happened to other people long ago and far away. I had no idea that 1/3 of the world's population is currently infected with latent TB. The multi-drug resistant TB epidemic in New York City that happened in the late 80s and early 90s, magnified considerably by HIV, had not happened yet. A lot of other things had not happened yet either. One interpretation of Plato's cave metaphor, this diagram is by Eva Braun, by the way, shows mathematical objects as a kind of entryway into the intelligible world where we can contemplate beauty and justice. Math is everywhere. What I'd like you to notice on this slide is that the fractal patterns on the right-hand side do an excellent job of capturing the underlying patterns of the cloud and the tree on the left-hand side. And then we had the experience of rigorous geometrical proof. What can compare with being able to say, quod erat demonstrandum, and know that you deserve it because you've earned it? Who would have imagined that these primordial shapes, Apollonius's definitions still are foundational in modern mathematics today, can be found simply by slicing a cone at different angles? This was my favorite class. Dedicated adherence to the circle as the most perfect shape may have seemed a little bit arbitrary when we were reading Ptolemy, but it is a beautiful thing how an epicycle can account for the apparent retrograde motion of the planets. We rediscovered for ourselves that the ratio of distances traveled by balls rolling down inclined planes is proportional to the ratio of the squares of the times. Did I say that right? It's a mouthful. Sweeping assumptions about the fundamental continuity of time and space are an essential prerequisite for calculus and also the type of disease modeling that I do in my work. Plus, monads are really fun to talk about. Going back to school at the age of 48 felt a little bit like jumping off a cliff. Although I actually have jumped off cliffs, and going back to school was a little bit more terrifying. Also a little bit more exhilarating. Johnnies are brave about learning new things. However, it was a shock to memorize this stuff for timed examinations in classrooms full of hyper-competitive 18-year-old students. This is a phase plane diagram. On the x-axis, we have the susceptible population. On the y, we have the infectious population. And you can see the pattern spiraling into the endemic equilibrium where a disease finds stability in a population. This really inspired me to study mathematical biology. This dot plot shows us the terrible paradox of antibiotic treatment. On the x-axis, we have increasing ability to detect and treat multi-drug resistant TB. As that happens, on the y-axis, we have increasing cases of extensively drug-resistant TB. I did this simulation that shows on the purple line the strain of drug-resistant TB that is resistant to every drug we have, is projected to outcompete all the other strains in approximately 200 years. That's with pretty conservative assumptions. On the other hand, when drug resistance has an evolutionary advantage, that is projected to happen about 50 years earlier, also with very conservative assumptions. So, we urgently need to explore alternatives to antibiotic treatment for Mycobacterium tuberculosis and also these other bacterial pathogens. Alternatives like hand washing, microbiome tuning, biofilm blocking, phage therapy, and vaccines. If we had an effective vaccine for tuberculosis right now, we could cut the prevalence in half in about 35 years, and we could completely eradicate it in about 150 years, according to my estimate. Every day in my job, I meet tasks I have no idea how to do when I first encounter them. I have my Johnnie methods: admit ignorance, ask questions, find a way. And thank you to my friends.